These results are using for the, we find for the lower cutoff frequency, higher cutoff frequency, bandwidth. For example, here getting for the value is a, the marker value is called as a, here 4.5 gigahertz, here minus 14.856 is a resonant frequency. We are getting for the less dB, 3 dB. We are getting for the lower cutoff frequency and the higher cutoff frequency. This is the between the lower and higher. It is representing as a bandwidth. So another is plot is helps to find for the impedance bandwidth also. And again we are modified. We going to modify the find for the fractional bandwidth also. In terms of, we are getting for the 20% more than greater, that is called as a ultra wideband frequency. We are getting for the 11%, we are getting for the wideband frequency. Less than 10% we are getting for the narrow band frequency. So these are the simulation we are received from this simulation tool. And we find for the some of the paper also. So with the help of the microstrip patch antenna, we find a variety of the paper publications, particularly antenna design. Here using for the, so the I used for the MRI coil. So the so the MRI coil for the some design of microstrip patch antenna, the coil for the RF heating and hyperthermia. This is a microstrip patch antenna. This microstrip patch antenna design, we are interacting some wearable applications, biomedical application. We find for the values, justification of the values. We find for the how much cancer in the soft cancerous cells. So these are one of the method. Another one is the same concept we are using for the another one, Springer electronic design material. So another shape of the microstrip patch antenna, this microstrip patch antenna shape we are implemented through the IoT applications. That is called as a defected ground plane. That is the back end is a defected ground plane. So back end is a different structure, front end is a different structure. So again we go into modified, we find for the result. So this is one of the paper that is called find for the hyperthermia. And recently one of the scholar find for the so this is the same one we are using for the by using some animal images are used in the Simlife 4, one of the tool I used. So find for the cancers, we are find for the cancer images, where tomography images directly find for this application. So another one is a AI driven antenna. This is a AI driven antenna we are using for the fractal shape. We are using for the fractal shapes. So for normally this is a structure length and width. We won't change any length and width during the iteration. Finally we are getting for the this iteration. The iteration structure we are applying for the different type of the iteration structure is normally each iteration getting for the 250 number of the data set. So we are gone through for the almost 7 iterations we are implemented in the neural network. We find for the deduction about the resonant frequency, that is helps to find for the radiation, that is the epochs, number of losses and epochs we find for the neural networks. So these are the article writing are using for the microstrip patch antenna. So because this is a real time scenario, so we going to find for the first mathematically we find the antenna, and after that we are using a simulation tool. After getting a simulation tool, we getting for the prototype. After the construction of this prototype, we go into test by the vector network analyzer. We find for the what is the resonant frequency, and similarly I shown for the S parameter. The S parameter plot we are getting for the VNA and vector network analyzer also. So it's an enormous application. We go into interacting for the virtually and also real-time application. That is one of the most emerging field. So many patch surface also we are changed. Different patch surface changed fractal antenna we are using. So recently one more color we are using for the fractal antenna. So that is a miniature type of antenna. Miniature type of antenna means the length is getting for the 10 centimeter cross 10 centimeter cross 10 centimeter. The structure is almost like as a patch paper size. This is one of the Kapton material. Kapton is one of the rare material. So this antenna fabricated Kapton. So patch and another one is a defective ground plane structure we are used. So this is a miniature antenna. This antenna is a fractal type of antenna. So fractal type of antenna. So same antenna we are used for the different structure. This is a so I shown for the published paper. Such antenna is a defective ground phase structure, that is a fractal antenna. This antenna is our purpose we are designing for we are improving for the wideband frequency. Sir using for the single side antenna, that is a full grounded structure. So these kind of antennas we are using, but these antennas are using for the wearable application also. We going to find for the cancerous applications or any other on body centric application. Such application we going to test by these kind of antennas. So thank you for the session, Dr. Ramas sir, Professor, Department of EEE. Thank you sir. Thank you madam, coordinator madam. Thank you all.